The tricky part with this inequality is the interval notation. So let's look at that. Let's deal with the x is less than or equal to -1 first. That means x can be as low as -infinity or as high as -1 inclusive. We also know, though, that x can be greater than or equal to 5. So x can be as low as 5 inclusive and as high as positive infinity. What we do then is we use this symbol here. It looks kind of like a U, but without the little leg on the side. And it literally means or. So for our interval notation, we know that x can lie in the first interval of -infinity to -1, or x can lie in the second interval of 5 to infinity. Okay, here are your last two absolute value inequality problems. Go ahead, try them on your own, pause the video, and come back when you're ready. For this first one, you should always be cautious when you have an absolute value set in an inequality or an equation to a negative value, which we have with both of these. In this first one, let's think about this. Absolute values are always positive. So is it possible to take the absolute value of a number and have that number be less than or equal to -12? Hopefully you realize it's not, because no matter what our number is inside the absolute value, it will always be a positive number, and therefore it cannot be less than or equal to -12. So for part C, we have no solution. You can also represent this with an empty pair of brackets that indicates there are no possible solutions to put within that bracket set. Okay, let's look at the second one. We have an absolute value that's set greater than or equal to a negative number. Again, we know that an absolute value will always be positive, and a positive number will always be greater than or equal to -12, meaning no matter what x is, this inequality will hold true. So x can be all real numbers. Alright, now that we've gone through some of the basic problems, take a moment and try this more in-depth word problem. We have a company, and a company makes Sing-Along-Elmo dolls. The company allows for an average of 5 defective Elmo dolls per every 1,000 tested. The company tests 4 batches of Elmo dolls, so that means they test 1,000 Elmo dolls 4 times, and finds that an average of 4.75 dolls are defective per batch. So these are 4 batches. We have 4.75 dolls per batch as defective. How many Elmo dolls can be defective in the 5th batch in order to keep below the 5 defective Elmo average? Take a moment, think about this, process this. This is something that happens with companies, whether the company is making computer parts, soda cans, whatever. Defective materials always happen. There are always some amount of defective product. And companies just have a maximum average amount of defective products that they make. So this is a very real situation that occurs in the business world. Once you're ready, go on to the last video for this topic of 1.6 and see the solution.